That's good to go. Great. Back button. Okay. Back button does work. Great. Hi, everyone. I'm Dave Howcroft. I'm a research fellow up at Edinburgh Napier University. And my talk today is going to be a bit of a survey of the landscape for Scottish Gaelic in NLP today. A similar theme, similar structure, actually, thinking about where we have been, where we are now, where we want to go in the future. Also, as mentioned in other talks, this work's not possible without a lot of other people. So I'll only be talking about my work with these collaborators for a small part of the talk, but I'd like to acknowledge Dimitra, working with me at Napier, Will Lamb, upon whose work a lot of this talk relies, B. Alex and Anna Groundwater from University of Edinburgh and the National Museum of Scotland, respectively, who have also been involved in sort of my own work and the work that we're planning going forward. So since I'm the first person speaking about Scottish Gaelic today, I'll give you just a high-level overview of this. So we've got about 60,000 speakers in Scotland. This is just people who indicated on the 2011 census that they could speak some Scottish Gaelic. It's a Gaelic language along with Irish and Manx. And this map shows you the distribution of the language across the country, where each cell is highlighted based on what proportion of the local speakers speak the language. So what you can see importantly is that it's only really in the in the Outer Hebrides that you get a majority of the population able to speak the language. So there might be more learners currently in, say, Edinburgh and Glasgow down here in the Central Belt, but they don't have the opportunity to use the language in their daily lives unless they're, say, attending a Gaelic medium school or something like that. So that's a bit of the background for the language itself. I want to start by talking about the available resources for doing NLP with Scottish Gaelic. So this is just a high-level overview of several of the corpora that are available. And you'll see that I've mixed the definitions of corpus in here as well. So the earliest work comes from this Arcos data set collected originally in the 90s and made public in like 2016. But the sort of common theme among these data sets is that they're quite small by NLP standards, right? Tens of thousands or maybe 100,000 tokens. They include a mixture of both spoken and written language, and it's not until you start getting into more recent data sets that you finally have millions of tokens. So one of these is a corpus only in the NLP sense. So the Crubadan is crawled web data. So that's from Kevin Scannell as well. And then the Corpus Nagalic is the largest data set that we have available today with about 30 million tokens. So I've also included the sort of availability of these different corpora here, but I want to put the size of these data sets in context compared to some high resource languages. So just looking at English for a moment, the corpus of contemporary American English contains 1 billion tokens spanning 20 years. And that's a proper corpus, representative samples that are meant to be used for doing linguistic work or other corpus analysis. The C4 is based on what's called the Common Crawl, which includes 9 billion websites that have been crawled. And this is a subset of the data that is supposed to just be English, and that's got 156 billion tokens. So this is the sort of data availability for English contrasted with Scottish Gaelic. The last piece of the puzzle that I want to include is just a rule of thumb for developing large language models. So the smallest thing that is commonly called a large language model would have about 700 million parameters in the model. And training one of those models takes about 2 billion tokens of the language that you're using. So we're quite a long ways off from being able to develop that kind of large language model for Scottish Gaelic. So that's the data that we have available. What sort of research and technologies have people been developing for Scottish Gaelic so far? So there have been good advances in sort of core NLP technologies to do things like part of speech tagging, syntactic parsing, lemmatization, where you're identifying the dictionary form of a word, machine translation, speech and handwriting recognition, and also in standardization. There's been less work on things like speech synthesis or natural language generation, and almost no progress in semantic annotations or things like conversational agents or natural language understanding. So to talk about these in more detail, let's focus first on the ones that are helping us to enlarge our data sets, since we need to build up these corpora further. So first I want to talk about the state of the art in handwriting recognition for Scottish Gaelic. So we have a lot of data available from folklorists and other researchers over the years that's only available in a handwritten form, right? We've got these large archives. Many of them aren't even fully digitized yet, let alone have optical character recognition done so that we can then process the data further. So here you're trying to take some raw text like this. This is from a hand that is particularly well represented in some of the work that I'm talking about here, where they get quite good performance. So you can see the letters in the bottom portion, even if you don't speak Scottish Gaelic, look like they could be the right ones from the text above. So this is taken from this work of Sinclair et al. From 2022, where they digitized about 2,000 pages of text and transcribed them. So they ended up with a corpus of more than 370,000 words. And I want to share some of the detail of their process. So they began just manual transcription to get the first 18,000 tokens. That work took about 75 person-hours and gave them a starting point to start training their handwriting recognition system. When they then did the next 18,000 tokens, it took almost the same amount of time using that model and correcting the outputs. However, at that point, once they had done those first two rounds, getting more than 30,000 tokens transcribed, then they reached this sort of critical mass where the handwriting recognition actually sped up the process. So they went from processing about 240 words per hour to almost 900 words per hour. So much, much faster corpus building at that point. More recent, so they achieved quite a good word error rate and character error rate on this. For the dominant hand, the one that I showed a picture of, they had very low rates, and these rates approximately tripled. As far as I can tell from the few papers that I looked at in English, this performance for handwriting recognition is quite similar to what you can achieve for English texts. More recently, there's this work by O'Rahale et al. From 2022 and ongoing, where they're semi-automatically transcribing millions of words in Gaelic and Irish. So I don't have more details on that at the moment, but there is ongoing work further developing handwriting recognition. Similarly, we want to leverage all of these spoken language corpora. So the BBC has hours and hours of spoken Scottish Gaelic, and it would be great if we could expand our data sets by transcribing that. About a decade ago, some earlier work in speech recognition focused on 6 hours of studio speech, so very tightly controlled language, and managed to achieve a word error rate of about 23. So for context, the point at which speech recognition begins to be helpful for transcription and actually speed things up, the sort of rule of thumb is a word error rate of 20 words out of every 100 or less. So 1 in 5 words can be an error and it can be useful. But any higher than that, and it's not very useful. So more recent work from Evans et al. Has used a larger corpus of speech and 8.5 million words of text as well for language modeling. And this corpus, the data that they're working with, is much more representative of the actual spoken language. And with this, they had a slightly worse error rate, so it's still not quite at that point where we would use it to speed up all of our transcription, but we're getting there. And this is, again, with much more representative data. And out of that project also came an aligner for aligning text-to-speech, a digit verbalizer so that you can take just a numeric expression and get the correct Gaelic pronunciation of it, and also a grapheme to phoneme model for converting from the written language to a phonetic or a phonemic representation of that. So these are some of that's the current state of the NLP tools that we can use for expanding our data sets. What can we actually do when we want to analyze some Scottish Gaelic data? So one resource from Boiseau and Lamb 2020 is this website, the Gaelic Linguistic Analyzer, which is available, that provides part of speech tagging with quite good performance. So 90% accuracy on a very large tag set, but almost 95% accuracy on a much smaller tag set. I think part of speech tagging for English is in the sort of 97% range. Or even higher, so still some ways to go, but this is already sufficient to be helpful. There's not a formal evaluation of the lemmatizer that's included in this. However, it's been described as suitably accurate for general use, so take that as you will. And it's also got a syntactic parser that uses the universal dependencies representation as its target, which achieves a label detachment score ranging from 91 to 97%, which is quite good for a dependency parser. So that's one resource available to us. And I've even got a link for you if you'd like to check it out yourselves. With respect to machine translation, I'm going to focus on a couple of core pieces of work. So one piece of work is this Intergallic from Scannell. So especially focusing on the 2014 work from Gaelic to Irish. This work used about 1 million words and achieved a word error rate of about 40%. Now for context, the word error rate is almost 90% if you just treat the Scottish Gaelic text as Irish text. But for context as well, word error rate is basically like Levenstein distance on words. So it's quite a coarse measure that doesn't deal well with things like reordering or a different word form appearing. So this 40% error rate is actually like fairly reasonable, I think. More recent work from Dowling et al. Has looked at data augmentation through back translation, so using a pivot language to produce more training data for your translation model. And through this data augmentation process, they did find that their BLE scores improved. So BLE was mentioned earlier. It's a sort of standard metric in machine translation. And it also uses word overlap, but is a bit more forgiving than word error rate is. Finally, there are some commercial offerings available, right? So you can use Google Translate, and it's improved markedly, especially for, I believe, translation into Gaelic is better than out of. I'm not 100% sure on that. Is it the other way around? From Gaelic, sorry. Thanks. And it's even available in ChatGPT, though from what I've been told, the Gaelic that it produces is like that of a particular kind of autodidact, like self-taught speaker of the language, as opposed to someone embedded in the community. And so it's not necessarily so representative, but can be used for some MT there as well. I want to talk briefly about the bit of work that we did building up a data set for natural language generation. So so natural language generation in Scottish Gaelic hasn't received very much attention so far. And our idea, sorry, the title should be behind this image, was to build a data set of conversations. The idea is that this would model the kinds of conversations that visitors to a museum might have with a museum curator. The idea being that this would be something that you could integrate into chatbots so that museum visitors doing their own, having their own guided tour through their cell phone of a museum could learn about these artifacts in their preferred language, in this case Scottish Gaelic. So users saw both the person playing the curator role and the visitor role received an image like this. The curator would receive a bunch of information about the exhibit, and the visitor would then ask them questions to try to learn about it. Now, it was mentioned in the previous talk as well that data collection could be a particular challenge. Indeed, here we were collecting sort of first-hand data, recruiting participants, and in the end, after about 6 months of recruiting, we had only managed to get 24 people to sign up to do our study. So our corpus ended up being about 1/10 the size of what we wanted, with just about 60 conversations and 100 summaries. So we would have the users summarize their conversations after the fact as well, so that the data set could be repurposed as well for sort of dialogue summarization tasks. So this is a first step towards being able to develop these chatbots for Scottish Gaelic. There's been a bit of work on speech synthesis as well. So already in the 90s, there was some work using simple diphone models. This work targeted in particular the Lewis accent, and it's described as intelligible, but clearly exhibiting that accent and overall sort of low quality, so not something that you would be ready to just take off the shelf and use. More recently, there was a collaboration during the 2010s, an academic industrial partnership which used 30 hours of recording from a BBC presenter with the mid-Minch accent. So this is supposed to be a sort of neutral-ish, standard-ish accent. And this is available through Cereproc. You can get it on your phone if you want to try it out. But this is sort of all of the work that's been done in speech synthesis so far. And one of the themes that you can notice, if you contrast this with the talk about Welsh and Maxon, right? These tools are not all integrated into one nice interface for everyone to use. It's different projects here and there over the years. Finally, also with building up our corpora, right? One of the things that we need to do if we're trying to develop NLP tools based on them is some kind of orthographic standardization to make things a bit easier for our models to get to grips with. So the idea here is to limit unhelpful complexity, it's described as. Now, this unhelpful complexity phrasing is, it's particularly important to put it in context, right? This is unhelpful with respect to developing NLP models. This complexity is actually quite important, as Maren mentioned earlier, in terms of the actual variation within communities and how people choose to express themselves in a language, right? And I don't have any answers for how we work within the context of our limited resources to ensure that we can support that degree of variation as well. So this targets the Gaelic orthographic conventions from 2009, and they developed first a rule-based system that achieved a pretty good performance, character error rate of about 3, word error rate of about 10. And you can see, so more recently they've tried to develop a transformer-based, so a neural network-based model, and they haven't quite achieved the same performance as their rule-based model yet. And they make different kinds of errors. So the rule-based model doesn't tend to insert errors into the text in the same way that the machine learning model might. But the machine learning model also deals better with like unusual spelling choices or less frequent or texts that have a lot of errors where the rule-based system might fall down. My closing slide is a bit messed up, but I've talked a bit about the corpora that are available. So the largest that we've got today is about 30 million tokens. We have made progress for a lot of sort of basic NLP tasks that help us for analysis, but these aren't really integrated, and we are still lacking some key things like semantic annotations of interest to me, conversational agents, natural language understanding, natural language generation, and there could also be some more work in speech synthesis. So if you've enjoyed this talk, I encourage you to look out for Lam and Franson in press. This is a chapter in the Palgrave Handbook of Celtic Languages and Linguistics. So it should be coming out soon, and I've relied heavily on this work from Will Lamb, my collaborator, in preparing this overview for you today. With that, I'd like to thank you and welcome any questions you have.
Any questions? Try to change like the.
Thank you very much. Very interesting. I'm really pleased to see so much work on actually NLP for Gaelic. So I just wanted to ask you, you provided the performance rates for part-of-speech tagging, which was very promising. You provided a rate for not for syntactic parsing. It was only for prepositional attachment delineations.
No, it wasn't just prepositional attachment. So the labeled attachment score is for the universal dependencies parse. Both the like the directionality and the labels of parses.
This would be the performance rate for the parser, right?
Yeah.
This is astonishing because for English the best results I've seen are around 90%. So this is even better than English. And then what about sentence splitting, which is a fairly easy task?
I unfortunately do not know about sentence splitting performance off the top of my head.
Any quick question? Cool. Thank you very much. Really.
Thank you.